Hey Chemistry, Mrs. KJ here, going over Lesson 2.03, Atomic Number and Mass Number. And I will warn you, these two concepts are going to be used the rest of the year. So as always, but especially now, if you're feeling confused, please come see me. All right, let's look at atom characteristics. We have the atomic number, which is simply the number of protons. We also have the mass number, which is the sum of, so you add the number of protons plus the number of neutrons. An atom's atomic number is the same as the number of protons in its nucleus. In this lesson, you will learn how to determine the atomic number and mass number of any individual atom. Knowing the atomic number of an electrically neutral atom will enable you to determine the number of electrons an individual atom has. So remember, if it's electronically neutral, that means the number of protons and the number of the electrons are the same. Goals for this lesson: define an atom's atomic number, define an atom's mass number, distinguish the mass number of an atom from its atomic number. You can download the study guide. The characteristics of each element depend on the nature of the atoms. So let's look at the picture here, and this is what lithium looks like. Kind of looks like a little mini chocolate bar, doesn't it? And that's because the outside is oxidized, and they cut it open so you can see how bright and silvery it is in the middle. And if we look, how many protons does lithium have? 3. And when it's electronically neutral, how many electrons? 3. And how many neutrons? 4. If we look at beryllium ore and the beryllium atom, we can see now that there are how many protons and electrons in this electronically neutral atom? 4 of each. And we can see a total of 5 neutrons. Lithium and beryllium are two elements. Both are metallic, solid elements that are gray or silvery in color in their pure form. Lithium compounds are used in some mental health drugs. Beryllium is used in materials from ball bearings to aircraft engines. What makes lithium an element that is unique and distinct from beryllium? You know that an atom has a nucleus that contains protons and neutrons, and that is surrounded by electrons. As you will find out, the part of one atom that most distinguishes one element from another, for example, how lithium differs from beryllium, is the number of protons in the atoms that make up the element. So, protons are the most important thing for telling which element an atom is. The number of protons in an atom is that atom's atomic number. What makes the atoms of one element different from those of another? The answer lies within the nucleus. It is the number of protons within the nucleus of an atom that makes the atom unique. For example, every atom of lithium has 3 protons in its nucleus. Always, 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 always. That's that atom's number. It's like the ID number or the Social Security number. Anytime you have 3 protons, you always have lithium. The number of neutrons can vary, the number of electrons can change. 3 protons, always, always, always lithium. Every atom of beryllium has 4 protons in the nucleus, always and forever. 4 protons means beryllium. Okay, so protons same, neutrons can change or be different between different atoms of the same element, and you can lose and gain or share electrons, which we'll be talking more about those later, but protons determine what element an atom is. The number of protons in an individual atom is so distinguishing that the number of protons is given a special name. The number of protons an atom has is its atomic number. Think of it as like atom apostrophe S, the atom's number, atomic number. The atomic number of lithium is 3 because every atom of lithium in the universe that exists has 3 protons, always and forever. The atomic number of beryllium is 4 because every atom of beryllium on Earth and throughout the universe has 4 protons, always and forever. All right, so let's stop there and make sure we add that to our notes. I left the introduction paragraph and the goals. Atomic number, the number of protons within the nucleus of an individual atom. So the number of protons tells which element it is. Always and forever. Aren't you happy I'm not singing that at least? All right. The number of neutrons plus the number of protons in an atom is the atom's mass number. All right, let's stop and think. Mass is kind of like weight. So if we want to talk about how heavy the atom is, we need to add up everything that has a significant amount of mass or weight in it. That would be the protons and the neutrons. Do you remember how much each one weighs, or the mass? We say the mass is 1 AMU for protons and 1 AMU for neutrons. Electrons, remember I said they're so tiny? It's like if you weigh yourself before a haircut and after a haircut, the scale is going to say you weigh the same, even though you have less hair on your head, because the hair just doesn't weigh that much compared to the rest of your body. So same thing, we ignore electrons when we find the mass, we just add the number of protons and neutrons. Now you know how important protons are in determining an atom's identity, but what about the other particle that's found in the nucleus of an atom? That particle is the neutron. Sometimes the number of neutrons equals that of protons in the same nucleus, but more often than not, the two numbers are not equal. A proton and a neutron are about equal in mass, close enough that we call them each 1, AMU. Remember, we don't use grams because it would be too tiny. So a count of the number of protons plus the number of neutrons gives a good estimate of the mass of the atom. The number of protons plus the number of neutrons in an atom's nucleus is that atom's mass number. So if I have 10 neutrons and 10 protons, my mass number is 20. Every neon atom has 10 protons, but the mass numbers of neon atoms can differ because the number of neutrons in an atom can differ. So in this atom of neon, it's still neon because it has 10 protons. Neon is number 10 on the periodic table. That's how I know it is still neon. This version, or this atom of neon, has 11 neutrons, so the mass number is 21. And now I have 12 neutrons, 10 protons, add them together for my mass number of 22. However, I know it is still neon. Why? Because it has 10 protons. And it's number 10 on the periodic table because its atomic number is 10 because it has 10 protons. All right, so let's talk about our mass number, the number of protons plus the number of neutrons within the nucleus of an atom. Every proton has a mass of 1 AMU. Every neutron has a mass of 1 AMU. We say electrons basically have a mass of 0, which is why we ignore them when we say what is the mass of the atom. The atomic number and the mass number of an atom tell about the organization of its nucleus. So let's look at the picture first. We have lithium, number 3. That's the atomic number, which is the same as the number of protons. There's my symbol, Li stands for lithium, and the average atomic mass number. So the average atomic mass, because you have isotopes. In other words, it's like this. Some atoms of an element have more neutrons than others. Some of them are fatter than others, basically. But because they all have 3 protons, they are all lithium. So we round it up. We say this is about 7. So if my mass is 7 and I have 3 protons, how many neutrons do I have? All right, use what you have just learned to explore some individual atoms. Look at the periodic table. You may remember the periodic table from other science courses you have taken. Find lithium on the periodic table. Assume that you have a block of lithium in front of you and that you examine just one atom of lithium. You find that this one atom has an atomic number of 3 and a mass number of 7. What is the structure of the nucleus? Lithium must have 3 protons in the nucleus since the atomic number is always equal to the number of protons. That atom then must have 4 neutrons in the nucleus. Why? Because the mass is 7. 3 of that is because of the 3 protons, which means the leftover mass is due to 4 neutrons. Remember that the mass number of an atom is equal to the number of protons plus the number of neutrons. The term average atomic mass is discussed in another lesson. Okay, so for now, we said if you take the number of protons plus the number of neutrons, what do you get? That's the mass number, right? Okay, so if I take the mass number minus the number of protons, what does that tell me? And that is going to tell me the number of neutrons. Now I wrote the mass number minus the atomic number equals the number of neutrons. Does that make sense why these two are, it's not selecting what I want, sorry. While these last two sentences are the same thing, because the number of protons is the same as the atomic number. So they indirectly tell you how many neutrons there are. So we round it to the nearest whole number. We say it's 7, 7 minus 3. Most atoms of lithium have 4 neutrons. All of them have 3 protons. So again, there's a reason why this is a decimal. We'll talk about that later. And I'm going to just say round to whole number. So you either round up, or if you don't round up, you round down, which really means leave the number the same. So round to a whole number. So very important because you cannot have part of a proton or part of a neutron. You either have one or you don't, so that's why we round. So 6.9 rounds to 7. You can determine the mass number and the atomic number of an atom. So let's look at another element. Silicon has the chemical symbol Si. Silicon is abundant in the Earth's crust and is found in many materials, including glass and ceramics. Glass is silicon dioxide. So silicon, di meaning 2, oxide standing for what? Oxygen. So it's silicon and 2 oxygens. You probably know that a silicon chip is a key component in all computers. Silicon has an atomic number of 14. What does that mean? That means it has 14 protons. Now assume that an atom of silicon exists that has a mass number of 30. Okay, how many neutrons does this atom have? Well, the total mass is 30. The only subatomic particles that have mass that we actually care about and measure are the protons and neutrons. So if the total is 30, 14 of that is used up from the protons, what's left? And it would be 30 minus 14 is 16. That tells us that silicon has 16 what? Neutrons. All right, so since the atomic number of an atom is equal to the number of protons in the nucleus, you know immediately that there are 14 protons in the nucleus of an atom of silicon. The mass number of an atom is equal to the number of protons plus the number of neutrons. So there are 16 neutrons in the nucleus of this specific silicon atom because 30 minus 14 equals 16. And sorry, I said silicone, it's silicon. But we talk more about silicone, so sometimes I read too fast and forget to pronounce it as it is as an element. Now, this example is not the same as this example. This example, the mass number is 28, 28.086, so it rounds down to 28. So if my mass is 28, and we know that you have how many protons? Well, you know that you have 14. 28 minus 14 means this example has how many neutrons? 14. So if you're saying, well, then why did they say it was 30? Because remember, you can have different numbers of neutrons with the same element. You can always find out an atom's atomic number by using the periodic table. Look at neon. Can you find it on the periodic table? Neon's symbol is Ne, and its atomic number is 10. Neon is a gas that is found in traces in Earth's atmosphere and is used in neon signs. If neon's atomic number is 10, then every atom of neon in the whole universe has 10 protons. Now assume that an atom of neon exists that has a mass of 22. If there are 10 protons in the nucleus, and the number of protons plus the number of neutrons is equal to the mass number, then the number of neutrons equals 22 minus 10 equals 12 neutrons. There are 12 neutrons in this specific atom of neon. Again, this example is different. According to this, what's the mass number? 20. The mass number is 20. The atomic number is 10. How many neutrons does this have? 20 minus 10 is 10. So 10 protons and 10 neutrons. An electrically neutral atom has an equal number of protons and electrons. And I'll start this one on the next video link.